Hello students, welcome to Standard 12th Chemistry by Sujata Miss, Fatima Convent High School. Unit 10, Haloalkanes and Haloarenes. Today's our topic is elimination reaction. Before moving on to elimination reaction, let us discuss alpha carbon and beta carbon. For that we will consider this molecule. Location of alpha and beta carbon in a molecule. Carbon on which halogen atom is directly attached is called alpha carbon. So this is the carbon on which halogen is attached, it's alpha carbon, and this is beta carbon. And the carbon atom adjacent to this carbon is called as beta carbon. Elimination reactions. When a haloalkane with beta hydrogen atom is heated with alcoholic solution of potassium hydroxide, there is elimination. Elimination means removal of hydrogen atom from beta carbon and halogen atom from alpha carbon. So here as a result, C double bond C, that is alkene, is formed as a product. Since beta hydrogen atom is involved in elimination, it can often be called as beta elimination reaction. If there is a possibility of formation of more than one alkene due to the availability of more than one beta hydrogen atoms, then usually one alkene is formed as a major product, that is in more amount, and the other as a minor product. Now based on this, Sedsev gave a rule which is known as Sedsev's rule. In dehydrohalogenation reaction, the preferred product, that is a major product, is that alkene which has greater number of alkyl groups attached to the doubly bonded carbon atoms. That is, doubly bonded carbon should be attached to more alkyl groups will give the major product. For example, in elimination reaction of 2-bromopentane, it gives two products, pent-2-ene, that is the double bond is on second carbon from here, and here we have the double bond on the first carbon, and pent-1-ene. Now pent-2-ene has a double bond carbon which is attached to the more number of alkyl groups, that is greater number of alkyl groups, so it is obtained as a major product. Beta elimination reaction is also known as dehydrohalogenation reaction. For your memory aid, you can remember wherever you have a De, it means removal. Here hydrogen as well as halogen is removed, so dehydrohalogenation only for your memory. Now over here, alcoholic KOH is used for the reaction, remember. Now here we have the alpha carbon, that is the carbon which is attached to the functional group. The adjacent carbon to alpha carbon is known as beta carbon. So this is the beta carbon over here and this is the beta carbon. Now when hydrogen of this carbon is removed, we get a product like this, that is pent-2-ene. A double bond is formed over here. Now when you go for removal of hydrogen from this beta carbon, we get a product like this, which is pent-1-ene. Now if you see, this doubly bonded carbon is attached to one alkyl group over here and the second alkyl group over here, whereas this doubly bonded carbons are attached to only one alkyl group. So you can say that pent-2-ene will be the major product, whereas pent-1-ene will be the minor product. Reaction with metals. Most organic chlorides, bromides and iodides react with certain metals to give compounds containing carbon-metal bonds. Such compounds are known as organometallic compounds. An important class of organometallic compounds was discovered by Victor Grignard and is alkyl magnesium halide, that is RMgX, which is known as Grignard reagent. These reagents are obtained by reaction of haloalkane with magnesium metal in dry ether. So here we have haloalkane, that is alkyl halide plus magnesium metal in dry ether to give you Grignard reagent, which is RMgX. Here R refers to alkyl group, that is CH3CH2 or any other alkyl group. Here in Grignard reagent, the carbon magnesium bond is covalent but highly polar. So here the bond is polar with carbon pulling electrons from electropositive magnesium, whereas the magnesium halogen bond is ionic. Now Grignard reagents are highly reactive and they react with any source of proton to give hydrocarbons. Even they react with water, alcohols, amines. It is therefore necessary to avoid even traces of moisture from a Grignard reagent. That is why reaction is carried out in dry ether. Next we have Wurtz reaction. Alkyl halides react with sodium in dry ether to give hydrocarbons containing double the number of carbon atoms present in the halide. The reaction is known as Wurtz reaction. So here if you have one carbon in the reactant, then you will get in the product 2 carbon atoms. Here if you have 2 carbon atoms, you will get the product with 4 carbon atoms. That is, the product is obtained with double the number of carbon atoms present in the halide. So here the reaction is 2Rx plus 2Na gives you the product with double the number of carbon atoms plus 2NaX. Thank you for today and meet you with the next video.